trigonometric products as sums and differences. So here we're going to look at taking our compound angle results and changing them around a little bit so we can express products of sines and causes in terms of sums of sines and causes, or the other way around, expressing sums and products as products. So in order to do this, we're going to need to write out our compound angle results. So we've got sine theta plus alpha equals sine theta cos alpha plus cos theta sine alpha. We've got sine theta minus alpha equals sine theta cos alpha minus cos theta sine alpha. We've got cos theta plus alpha equals cos theta cos alpha minus sine theta sine alpha. And we've got cos theta minus alpha is cos theta cos alpha plus sine theta sine alpha. Now, we're going to call this equation 1, equation 2, equation 3, and equation 4. And all we're going to do is get some more expressions by either adding or subtracting some of these equations together. So the first one we're going to look at is if we take equation 1 and add it with equation 2. So let's do the right-hand side first. So taking equation 1 and adding it with equation 2, you'll see that these last two terms will cancel out, cos theta sine alpha and cos theta sine alpha, because they're opposite signs when we add them together. And the right-hand side will give us 2 sine theta cos alpha equals, and the left-hand side will give us sine of theta plus alpha plus sine theta minus alpha. And then if we multiply both sides by a half, the 2 will go to that side. So we'll just get rid of it there. And this is our first result. And here we've successfully got an expression that takes a product of a sine and a cos term and expresses it as a sum of sine terms. So our next one, we're going to do equation 1 minus equation 2. And again, let's start with the right-hand side. So we're going to do equation 1 minus equation 2. These first two terms will cancel out. And this minus this will end up being plus because it's minus minus. And we end up getting 2 cos theta sine alpha equaling, now again we're going equation 1 minus equation 2. So then we get this term minus this term on the right hand side. So we get sine theta plus alpha minus sine theta minus alpha. And again, let's times both sides by a half. So this half will go here and it will cancel out with the half on the left, the 2 on the left hand side. All right, next equation, let's go 3 plus 4. So if we do that, again, let's start with the right-hand side. So this time, these two terms will cancel out because they're opposite sign, and we'll get 2 times cos theta cos alpha, and then adding the left-hand sides, we're just going to get these two terms added together. So we're going to get cos of theta plus alpha plus cos of theta minus alpha. And again, Let's times both sides by a half, which will cancel out with that 2 out the front. Finally, let's do equation 4 minus equation 3. And we're going to get these two terms cancelling out this time. So that minus that will cancel, and then this minus this will end up being plus. So we'll get 2 sine theta sine alpha equaling, so we're doing 4 minus 3, so we're going to get cos of theta minus alpha at the front minus cos of theta plus alpha. And again, let's times both sides by a half, which will cancel out with this 2 out the front. And now we've got 4 equations that express trig products as trig sums. And we have 4 combinations. We have sine cos, cos sine, cos cos, and sine sine, all expressed in terms of either addition or subtraction of cos and sines. So how can we use these? Let's have a look at a question. Let's have a look at 2 sine of 3x cos 2x, and we want to express it as a sum or difference. So how can we express it as a sum or difference? Now, because we have a sine and a cos being multiplied, we could use any one of these two formula here to express it as a sum or a difference. Let's just go ahead and use this first one to express it as a sum. And we kind of want it to look like this. So you'll notice as a product, there's no 2 out the front. So what we want to do is, first of all, let's let theta equal 3x, and we'll let alpha equal 2x. So we can sub those into our formula. So let's pretend there was no 2 there. So we know we could express sine 3x cos 2x as a half of sine theta, which is 3x, plus alpha, which is 2x, plus sine theta, which is 3x, minus alpha, which is 2x. Close our bracket. We could times both sides by 2. So we get sine 3x cos 2x, exactly what we want to express. That half cancels on the right hand side because we've times both sides by 2. And then we get sine of 3x plus 2x, which is 5x, plus sine of 3x minus 2x, which is just sine x. And now we've taken 2 sine 3x cos 2x and expressed it as a sum. What about another example? Taking cos 6 theta times cos 3 theta and expressing it as a sum or difference. Now here, we've got a cos times a cos term. So we need to use this formula here. And again, let's go ahead and we'll let theta equal 6 theta, and we'll let alpha equal 3 theta. So we can express cos of 6 theta cos 3 theta is a half of cos of theta, which is 6 theta, plus alpha, which is 3 theta, plus cos of theta, which is 6 theta, minus alpha, which is 3 theta. We can simplify our right-hand side a little bit, so it's a half times cos of 6 theta plus 3 theta is 9 theta, plus cos of 6 theta minus 3 theta, which is 3 theta. And that's our expression. Let's look at one more example. Let's look at cos 8x plus cos 4x. This time we want to express it as a product. So you can see we have a sum and we need to express it as a product. Now, this time we have a representation of one of our right-hand sides as a sum or difference. So here we have a sum in terms of two causes. So it's looking very similar to this third equation here. And that's what we want to use. So just to visualize this, we know that 8x is representing our first term, which is theta plus alpha, and 4x is representing theta minus alpha. So if we just do a bit of work here, if we know that theta plus alpha equals 8x and theta minus alpha equals 4x, we can just solve these equations simultaneously to get our theta and alpha. So let's add them together and we'll get 2 theta equals 12x. So theta must have to equal 6x. And subbing that into any one of the equations, let's say subbing it into the first one here and solving for alpha, you can just minus 6x from both sides and we'll get alpha equals 2x. So now we know what our theta and our alpha should be. So let's go ahead and sub everything into the formula. So we're going to get cos of theta, which we know is 6x, times cos alpha, which we know is 2x, is going to equal a half outside of cos of theta, which is 6x, plus alpha, which is 2x, plus cos of theta, which is 6x, minus alpha, which is 2x. So let's times both sides by 2. So we're going to get 2 cos 6x, cos 2x, equals cos of 8x plus cos 4x. And now we've successfully turned our sum of cos 8x plus 4x into a product equaling 2 times cos 6x cos 2x.